Welcome back to our channel. So far, we have differentiated sums, products, and quotients. But what if a function is inside another function? For example, y equal to 3x plus 2 all that to the power 5, or y equal to sine of 2x. In these cases, we have a function inside of another function, a function inside of another function. So today, we'll learn the chain rule, which lets us differentiate composite functions. So first of all, what does this chain rule says? What does this chain rule says? For a function inside another function, the derivative is derivative of the outer function evaluated at the inner function, that is, derivative of outer function evaluated at the inner function multiplied by derivative of inner function. So in order to ease or to facilitate the application of said method, we're able to establish 5 simple rules in order to follow. First of all, we identify our outer function f of u and inner function g of x. Secondly, we differentiate outer function f of u, that is f prime of u. If you notice, we are differentiating the outer function with respect to the inner function u. Thirdly, substitute u by g of x. Fourthly, multiply by derivative of inner function, that is f prime of u, by the inner function, by the derivative of the inner function g prime of x. Fifth, we simplify if possible. So we are then going to take a simple example, example 1, which is an example on polynomial fractions, and apply set methods. So what does this example ask us to do? It tells us to differentiate y equal to 3x plus 2 all that to the power 5. Following our steps enlisted above, the first method or the first step to do was to identify our outer function f of u. So from this, what can we see? First of all, we notice that there are two functions in this case. We have our first function 3x plus 2 and our second function which tells us to put this first function to the fifth power. So we're having two functions. Our first function is 3x plus 2 and our second function tells us to put this first function to the fifth power. So from here, we can then identify our first function f of u, our outer function, as the function 3x plus 2 to the power 5, or let's say u to the power 5. If you notice, in this case, we have replaced our inner function here with the variable u. So to write it simply, our outer function will be let f of u be equal to u to the power 5. If you notice, our outer function was this fifth power. That means our outer function was the fifth power of this inner function. So all what we have done is let f of u be the outer function, which is the fifth power of any variable u. So our outer function here is u to the power 5. Identifying our inner function, we will say let g of x be equal to 3x plus 2. If you notice, our outer function is in terms of u and our inner function is in terms of x. Our inner function is the inner function, and our outer function is a function in terms of the inner function. So in order to facilitate the calculations, we replace the inner function by another variable u. So that is why our outer function is in terms of u, and u can be any inner function, and our inner function then is in terms of x. So moving on to our second step, which tells us to differentiate our outer function in terms of u, that is f prime of u. F prime of u, which is the same as the derivative with respect to u of u to the power 5. Don't be confused. It's not because in previous question we're using x. We are going to follow the same method to find the derivative of this function u to the power 5. Using the power rule, what does the power rule tell us? We put our power by the side, u, and we subtract our power by 1, which gives us 5 u to the power 4. Moving on to our third step, which tells us to substitute u by g of x. This implies that f prime is then going to be 5. What is u? They say substitute u by g of x. So let me write this better. U equal to g of x implies that f prime of u, which is equal to f prime of g of x, is then going to be equal to 5 into 3x plus 2, all that to the 4th power. If you notice, look at the initial formula. We have already calculated this term f prime of g of x. So moving on to our 4th step, which tells us to multiply by the derivative of the inner function, that is g prime of x. In order to do this, we first need to calculate the derivative of the inner function. So that's what we are going to do. G prime of x, which is same as the derivative with respect to x of g of x, is equal to derivative with respect to x of, what is our g of x? 3x plus 2 of 3x plus 2, which is same as 3 derivative with respect to x of x plus derivative with respect to x of 2. If you notice, in this case, I have used the sum rule, I have used the constant multiplier rule, and in order to facilitate this, it's going to give us 3 times derivative of x, which gives us 1x to the 1 minus 1, plus derivative of 2 using the constant rule gives us 0. This gives us 3 times 1, which gives us 3. So continue with our fifth step, tells us to multiply this term f prime of g times g prime. So f prime of g of x times g prime of x gives us 5 3x plus 2 to the power 4 times 3, which gives us 15 3x plus 2, all that to the 4th power. So what can we then conclude? Our conclusion can then be the derivative with respect to x of the term y, which is same as the derivative with respect to x, and what was our y? 3x plus 2, all that to the power 5, is equal to 15 3x plus 2 to the power 4. We enclose our answer. We are going to move on to a second example, that is our first practical example. Okay, we are still going to take another polynomial function. So let's take the function practice question 2. Practice question 1, sorry. Differentiate y equal to, let's say, 14x plus 5x squared to the power negative 1/3. Using the same steps above, first of all, identify our outer function and our inner function. What is our outer function? Our outer function is let f of u, not f of x, f of u be the function u to the power negative 1/3. You understand? Now identifying our inner function. Let g of x be equal to 14x plus 5x squared. Our second step asks us to find the derivative of the outer function, that is f prime of u, which is going to be the derivative with respect to u of u to the negative 1/3. Using our power rule, this gives us negative 1/3 times u to the power negative 1/3 minus 1, which gives us negative 1/3 u to the negative 4/3. Our next step asks us to multiply this term by the derivative of the inner function, that is f prime of u. Sorry, I skipped a step. Our next step asks us to replace u by g of x. So u equal to g of x implies that f prime of g of x is equal to negative 1/3. What was our g of x? Our g of x is 14x plus 5x squared. 14x plus 5x squared, or that to the negative 4/3. Our next step asks us to multiply this by the derivative of g of x. But first of all, we need to calculate the derivative of g of x. So g prime of x is equal to the derivative with respect to x of 14x plus 5x squared, which is same as the derivative with respect to x of 14x plus derivative with respect to x of 5x squared. That is from our sum rule, which is equal to 14 derivative with respect to x of x plus 5 derivative with respect to x of x squared. This is from our constant multiplier rule or multiple rule, equal to 14 derivative of x is 1 from previous examples, plus 5 derivative of x squared is 2x. This gives us 14 plus 10x. Our next step then asks us to multiply this and this. So f prime of g of x times g prime of x gives us negative 1/3 14x plus 5x squared to the negative 4/3 times 14 plus 10x, and this simplifies to negative 1/3 14 plus 10x into 14x plus 5x squared to the negative 4/3. So we can then conclude that therefore the derivative with respect to x of the function 14x plus 5x squared to the negative 1/3 to the negative 1/3 to the negative 1/3 is equal to negative 1/3 14 plus 10x 14x plus 5x squared negative 4/3. We always enclose our answer in a box. So we are going to take a third practical example, or a third example, that is a second practical example, to ensure this step is perfectly mastered, or this method is perfectly mastered. Practice example 2. Practice example 2. So we'll take a similar question, similar with a similar polynomial question. First of all, differentiate y equal to, let's say, 14 into 3x cubed minus 2 to the power half. Oh, let's take a question which looks a bit, we'll take a simple question, times 3x to the power negative half, all that to the fourth power. You notice, if you look very well, you notice that we can simplify this from the beginning and use the power rule directly to solve this, but we're not going to do that. We're going to use the chain rule, just to tell you that the chain rule is applicable no matter the situation. So let's work with that. First of all, identify our outer function and inner function. But before we do that, let's remove this 14. We notice that the derivative with respect to x of y, which is same as the derivative with respect to x of 14, 3x to the negative half, all that to the 4, is same as 14 times the derivative with respect to x of 3x to the negative half times to the power 4. So what can we then say? This is just an application of the constant multiple rule. So we are going to say let's say let z be this derivative. Let z be the term. Let z be the term 3x. Let z be the term 3x to the negative half, or that to the power 4, comma, such that y is equal to 14z. Now we are going to calculate the derivative of z. First term, find our outer term. Let f of u be equal to u to the power 4. This implies that f prime of u is equal to 4u to the 4 minus 3, 4 minus 1, 4 minus 1, which gives us 4u to the 3. Next, let g of x be equal to 3x to the negative half, implies that g prime of x is equal to 3 in bracket negative half x to the negative half minus 1, which gives us 3 negative 3 on 2 x to the minus 3 on 2. F prime of g of x, that is substituting u by g of x, is same as 4 into what is our g of x? 3x to the negative half to the power 3, which gives us 4 times 3, 12, x to the negative 3 on 2. Now multiplying f prime of g times g prime of x, f prime of g of x times g prime of x gives us negative 3 on 2, x to the negative 3 on 2 times 12 x to the negative 3 on 2. Knowing that both of them are like, yes, we can just add them multiply them normally. Negative 3 on 2 times 12 is same as negative 3 on 2 times 12, yes, times x to the negative 3 on 2 plus negative 3 on 2. Since it's a product, this gives us negative 18. 12 divided by 2 gives us 6 times negative 3, negative 18, times x, negative 3 on 2 plus negative 3 on 2, which gives us negative 6 on 2. Negative 6 on 2, which can still be written as negative 3, gives us negative 18 x to the negative 3. So what can we then conclude? Our derivative with respect to x of z is negative 18 x to the negative 3, and our derivative with respect to x of y, which is equal to what? 14 times, which is equal to 14 times our derivative with respect to x of z, and this gives us 14 times negative 18 x to the negative 3, and this gives us, what is 14 times negative 14 times 17, 14 times negative 18, it gives us negative 252 x to the negative, yes, 3, sorry, 3. We can then conclude that therefore derivative with respect to x of our function y gives us negative 2 x negative 3. Those answers. Let us verify using the previous method, that is simplifying our initial function directly and differentiating it. So what is our initial function? Our initial function is y is equal to 14 in bracket 3x half negative half order to the power 4. 14 is 14 3x half 3x negative half 3x negative half order to the 4. We can simplify that directly by 14 3 to the power 4 x to the negative half times 4 plus 14 3 to the power 4 27. Sorry, 3 to the power 4 81. An error. Yes. 81 x to the negative 2. What's 14 times 81? Yes, we have 1134 x to the negative 2. Now y prime, which is the differential or the derivative of y with respect to x, is 4 times negative 2 x to the negative 2 minus 1, which gives us yes. Which gives us which gives us 1134 times, which gives us negative 2268 x to the negative 3. So we can then conclude that the derivative with respect to x of y is equal to negative 2268 x to the negative 3. We enclose the answers. This is different from this because I just noticed we made an error, a simple error above here. This is equal to 4 times 3 to the 3 times x to the negative 1 on 2 times 3. 3 to the 3 here is 27. So this still has to be multiplied by 6. So this is, which gives us, which then gives us 108 x to the negative 3 on 2. So that is what I was supposed to use when performing this multiplication below here. When performing this multiplication here, where I multiplied this by this, I was supposed to add times 6 here, times 6 everywhere, times 6, times 6. So it was a simple error, times 6, times 6, times 6, times 6, times 6, which gives us negative 252 times 6. Sorry, times, another error. Times 9, 3 squared, yes, times 9, not times 9. Simple error again. So this is 108 times 9, not times 6. 12 times 9, which gives us, yes, 108. 108, yes, perfect. So yes, times 9, 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 times 9. And this gives us negative 252 times 9 gives us our correct answer. Negative 2268 x to the negative 3. So there was a simple error on which here, but the error is corrected already. So the question is perfect. We notice that using simplifying the initial question before performing the differentiation gave us the same answer as when we applied the chain rule initially. So still analyzing common mistakes students usually perform here. First of all, they forget to multiply by g prime of x. Secondly, they mix outer and inner functions. That is, they consider the inner function as the outer function or consider the outer function as the inner function. Thirdly, they try to differentiate inside first incorrectly. So they fail to differentiate this inside function. They fail to differentiate the outer or the inside function correctly. So we are going to thank you guys for watching this video. In the next video, we are going to go through differentiation or derivative of special functions like trig functions, exponential functions, and other special functions. So thank you. Waiting for you guys in the next video. Bye.